All right, folks, the last thing that we need to talk about is the division of complex numbers. And this can be easy or a little bit more advanced depending upon the setup. So let's talk about some basics here, folks. The first thing that you need to understand is something about fractions. If you have something of the form a plus b divided by c, you can break that up over the common denominator as a over c plus b over c. That's great. That's great algebra. What you cannot do is take something like a over b plus c and break that up into a over b plus a over c. Those do not have a common denominator. So this is a common denominator. And these are not a common denominator. So watch out for that kind of thing, folks. You don't want to be making noob mistakes like that. So just be careful. Now, what does that have to do with what we're going to talk about? Well, we're going to talk about some examples of division of complex numbers. And the first one we're going to talk about is something like 5 plus 15i divided by 5. This is complex divided by real. And in this case, all you're going to do is break this up as 5 over 5 plus 15i over 5. So we're going to break up into two fractions over the common denominator of 5. And this will simplify to be 1 plus 3i, and that's our result. The next thing that we need to talk about is division by an imaginary number. So if I have something like 6 plus 9i divided by 3i, this is complex divided by imaginary. What we need to do here is we can actually break this one up as well, although it's a little bit more complicated. This is 6 over 3i plus 9i over 3i. So we're going to break up over a common denominator of 3i, and we can try to simplify. I mean, 3 goes into 6 twice, so I could write this as 2 over I, and I cancel, and 9 over 3 is 3, and if I try to rewrite this as 3 plus 2 over I, we're a little bit unhappy about that because this is not the classic a plus bi form for a complex number. And that's how we want to write our answer. So we have to be clever here. We're going to take this, and a lot like rationalizing a denominator, we're going to make the denominator a real number. And we can do this here by multiplying by the number 1 in the most clever way possible. And I'm going to multiply top and bottom by I because I know that I times I is negative 1. So this is 3 plus, in the numerator I get 2i, and in the bottom I get I squared, which is 3 plus 2i divided by negative 1, which I can now write as 3 minus 2i. And now I have the proper complex form. So that's how you do a complex division by an imaginary number. Now we need to up the dose one last time. Our third example. This was 2. And this was example 1. 2 plus 3i divided by 1 minus I. This is complex divided by complex. And you're not going to break this one up yet. Do not break up over a common denominator yet. The first thing that we're going to do is we're going to take 2 plus 3i over 1 minus I, and we're going to make the denominator real. And we're going to do that by multiplying top and bottom by the conjugate of the denominator. 1 plus I, 1 plus I. Make the denominator real using the conjugate of the denominator. Because when you multiply complex conjugates together, you get a real number. So this is going to be, let's see, aside 1 minus I times 1 plus I is 1 times 1, which is 1, I, negative I, and negative I squared, which is 1 plus 0I, minus negative 1, which is 2. So this denominator becomes the real number 2. Now in the numerator, I'm going to have to FOIL. This is 2 times 1, which is 2. 2 times I, which is 2I. 3I times 1, which is 3I. And then plus 3I squared. Simplifying this, we get 2 plus 5I plus, remember that I squared is negative 1, so this will become a negative 3 as a result of multiplying by that complex number, all divided by 2. And if we collect our like terms here, what we get is the following. This is equal to negative 1 plus 5I all over 2. Now, while we still have a big fraction, we haven't written it in a plus bi form, but now we can break up into two terms. This is equal to negative 1 over 2 plus 5I over 2, which we often write as negative 1/2 plus 5 halves I with the I on the back end there. And this is the A quote-unquote plus bi form, where A is negative 1/2 and B is 5 halves. So there's our answer. Whoops. There's our answer. So let's try a couple more real quick. Example 4. 1 over 2 plus I. Simplify. Or I should say, not simplify, divide. All right, well, 1 over 2 plus I, all we're going to do here is multiply top and bottom by the conjugate of the denominator, which is 2 minus I. The numerator is just 2 minus I. The denominator is 2 times 2, which is 4, plus 2I minus 2I, and then minus I squared, which is 2 minus I over 4. The 2 i's will cancel, and negative I squared is a positive 1. And this becomes 2 minus I over 5, which we can break up as 2/5 minus 1/5 I. And that's our result. Let's do one more. 1 plus 2I over 3 minus I. Again, we're just going to use the same technique, no big deal. We'll multiply top and bottom by 3 plus I. And in the denominator, we're going to get 9 minus 3I plus 3I minus I squared when we FOIL. And in the numerator, we're going to get 3 plus I plus 6I plus 2I squared. So we can't cancel anything yet, but let's go ahead and clean this up and collect like terms. This is 3 plus 7I plus 2 times negative 1, if we rewrite I squared as negative 1 in the numerator. And in the denominator, we have 9 plus 0I minus negative 1 by rewriting the I squared in the denominator as negative 1. So, cleaning this up one last time, we have 3 minus 2, which is negative 1 plus 7I, over 9 plus 1, which is 10. And then we can break that up finally into two pieces as negative 1/10 plus 7/10 I. And that's our result for this complex division. And that's going to do it for this lecture on complex numbers.